supplementary and complementary angles. As we study geometry, we're going to look at the relationship between angles that are created in shapes and when lines, rays, or line segments intersect. Pause the video right now and match each diagram to its name and description. Hopefully you realized a line segment is a line that has two dots on either end to indicate stopping points or end points. And a ray has a starting point indicated by a dot and an arrow to indicate the pattern continues. And a line, patterns continue on lines in both directions. There are no end points. When lines, rays, and line segments intersect, they create what's called an angle. Okay, that's the space between them, and it's measured in degrees. Hopefully we already know how to interpret the relationship between the sum of angle ABC and angle ABD, and the sum of angle ABC and angle CBD. Pause the video, write that out, and fill in the blanks. Hopefully you ended up with the sum of the two angles here was 180 degrees because they're supplementary angles, and here they're 90 degrees because they're complementary angles. Again, pause the video and decide how you can relate the angles in this diagram. Hopefully you remember that angle BOC is equal to angle DOA because they're opposite angles. And hopefully you remember that angle COA is equal to angle BOD because they are also opposite angles. So to summarize, supplementary angles are along a straight line and they add to 180 degrees, and complementary angles create a right angle, so they add to 90 degrees. Now if I want to look in example 1, it says determine the values of the unknowns in the following diagrams and state all geometric properties used to solve for the unknowns. So what I'm looking for is the unknowns, and I'm going to state the properties. So if I look here, I see a right angle. That tells me I have 3 complementary angles. And complementary angles add to 90 degrees, so I can simply state x plus 2x plus 3x equals 90 degrees. Now my knowledge of algebra tells me that if I have like terms, I can add the coefficients. Well, these all have an x with an exponent of 1, so they are like terms. And if I simply see an x, its coefficient is 1, and I add them up. 1x plus 2x plus 3x will give me 6x, which is equal to 90. In order to solve for x, I have to remember I need to divide it into 6 groups. So I end up with 6x equals 90, and I have to divide both sides by 6, and I end up with x is 15. Now, not only am I solving for the unknowns, I'm looking for the missing angles too. So to solve for 2x, I have to multiply it by 15, and that angle has a value of 30 degrees. And the third angle is 3x, so when I multiply it by 15, its value is 45 degrees. Finally, determine the values of the unknowns in this diagram. Again, same thing, and I want to state the geometric properties again that I've used to solve it. So when I do that, I need to look, well, what's easiest? Obviously, y and 75 are on the same straight line, so they are supplementary angles, so I can add them up to get 180 degrees. Now, in order to isolate for y, I have to subtract 75 from both sides, and I end up with y is 105. Next, I need to figure out 3x minus 51. Well, 3x minus 51 and 75 are also supplementary angles, so I can add them together. My knowledge of solving equations tells me to simplify the left side before I move on. So 75 subtract 51 will leave me 24. Now I need to subtract 24 from both sides, and I end up with 3x is 156, but I have to share the 156 equally amongst the 3x's, so I divide, and x is 52. finally, I should substitute back in to figure out what that angle is. So it's 3 times 52 minus 51. 156 minus 51, and that angle has a value of 105 degrees.